a given source, which one of the following graph could represent the distribution of the energy E? Now, so let's look at the graph on the So the x-axis represents the amount of energy. Here I have zero energy and then more energy and more energy. And the axis N bracket E means the number of particles corresponding to that particular energy. So we see that for A, there's no energy, and then more particle increases and comes to a maximum for a particular energy, and then the number of particles reduces. And this one, and the number of particles increases and become flat for a range of energy and then increase again. This one, particles can have no energy at all, and then the number of particles remains more or less the same, and then suddenly there's no particle beyond a certain amount of energy. So all three are incorrect. For alpha particle, it should be like that, D. Actually, D is the correct graph for alpha particle as well as for gamma. They should behave like that. Remember I told you that for alpha and for gamma, they have a definite amount of energy. A particular amount of energy is immediate. So the graph should be like this one. And for A, it is for beta particle. If the question asks you about beta particle, the answer should be A. But for alpha or for gamma, the answer should be D. Okay. Now question number 2. Well, this one involves a little bit more discussion. It is a little bit more complicated for this one. Okay, so be careful. Two particles, R and S. The question do not tell you what they are. We don't know whether they are alpha particles or other kinds of charged particles. We don't know. We have no idea. We only say that they are particles. Move in a cloud chamber, placed in a uniform magnetic field. The magnetic field acts vertically out of the paper, so we can sketch it. The magnetic field should be like that. So we just use dot to represent magnetic field out of paper. Evenly spaced dots. Okay, you understand what I mean? Now I just place a few dots to remind the situation. As shown in the picture below, the tracks of R and S are circular, and the radius of the R track being half that of S track. Now, unfortunately, the question makes a mistake. What mistake you make? Well, the radius of the RS track should be shorter than the radius of R track. Do you agree? The S track is a smaller circle, while the R track is a larger circle. So the question makes a mistake. So it is difficult to determine the answer if the question itself is wrong. Now, which one of the following statements must be true? So you will look at this, we have must be. Not may be true, but must be true. So you have to rule out any possibility that whether it's wrong.嗱，呢度咧個題目話明要 must be true 嘅，所以咧你一定要排除晒所有嘅可能性，即係話有任何有懷疑嘅，有少少唔可，有少少機會唔啱嘅，其實都係唔係答案嚟嘅。咁所以即係要個要求好嚴格。And also, you read through the discussion again, it doesn't tell you whether the particle is coming from the left-hand side to the right or right-hand side to the left. There's no mention of this thing. 嗱，另外一個要留心嘅話咧，題目冇講俾你聽咧，到底咧啲 particle 咧係由左到右喐咧，由右到左喐喎。你唔好一廂情願咁以為咧佢一定係呢度出發，跟住咧裂開兩邊咁樣去喎。可唔可以我喺呢度打咁啱瞄準咗兩條啱啱打中嗰個位咧？其實都得噶嘛。So you need to be careful. So which one the correct answer? Now, let's look at it. D. Both R and S are positively charged. Well, we cannot determine what charge they have. The only thing we know is that they should have the same charge. What does actually, I can't even determine this one because, as I have told you, I don't know whether the path is from here to there or from there to here. So, suppose they are positive charged. Suppose they are positive charged, then what will happen? Now, the magnetic field is out of the paper like that, and obviously, the force acting on the particle should directly towards the center. So the force on R should be like that, and the force on S should be like that. These are the centripetal force directed towards the center. So the force should be like that. So a magnetic field out of paper and the force is pointing to that direction. So if they are positively charged, if the particles are positively charged, they should be moving along that direction. So that direction represents the direction of current. So if they are positive charged, they should move along that direction. So that the magnetic force created is pointing downward. Like that. And I use my right hand. This is kind of motor. So if you I used to use Fleming's left-hand rule. Okay, F, B, I. Force is like that. B is like that. Force here, magnetic field, all of paper. So the current should be along that direction. Okay. So on the other hand, if they are negatively charged particles, they should move from here to there. It's okay. It's okay. But the problem is that the description of question don't tell us whether it is moving from left to right, or maybe just one from left and the other from right. So maybe they just move like that. We don't know. So part D, both R and S are positive charge. We don't know. So we can't. It may be true, but as I have already told you, the question asked must be true. So here D cannot consider as must be true. Now, A, B, C, all these three answers involve about the speed or the mass. Now, how the speed and mass come into play? Let's figure out equation. Now, let's remind, I have a revision on the equations involving circular motions. Now, they are moving along a circular, the path is circular. So, the equation on circular motion apply in this case. So what are the relevant equations? Well, the centripetal force required to achieve that is equal to mv squared over r. So that one will be the centripetal force required to carry out this kind of circular motion. And the only source of centripetal force is from the magnetic force. When a charged particle is interact with the magnetic field. And the equation for the magnetic force is equal to BQV here. And obviously, this magnetic force is the only force that produces circular motion, so these two should have the equal sign. Now, B is the strength of magnetic field, Q is the charge, and V is the velocity of the particle. And both sides have the velocity V, so we cross out one, we eliminate one, and as a result, we can simplify the equation to give R just equals to mv divided by BQ. It's okay? Now the question tells us that one of the radius is half of the other. One of the radius is half of the other. And we also know that the two particles are traveling within the same magnetic field. So as a result, B should be the same for both particles. However, we have no information about the charge of the particle, or the mass of the particle, or the velocity of the particle. The question just didn't mention any of it. As a result, only information that out is half doesn't carry us far enough to determine which one should be the answer. We know that if they have the same mass or they have the same charge at the same time, then the velocity should be proportional to R. So for R to be half, then V should be half. We know that. Or if the question tells us that the velocity and charge are the same, then half the mass will half the radius. We can determine if we know that, but unfortunately the question doesn't tell us. So as a result, that question is a dead end. We don't have enough information to determine which should be the answer. 嗱呢個題目咧就玩大家嘅，因為咧佢冇俾到足夠嘅資料我哋咧係決定邊一個先係嗰個正確嘅答案。佢題目寫得好死，因為佢話明咧係 must be true 嘛，唔係 may be true 嘛。調翻轉頭 must be wrong 咧，我哋又可以揾得到喎。So if I ask in the other way, which of the answer must be wrong, then I will be able to give you some answer. Actually, even that I can't, because there are too much variable. It only tells you some particles is inside the cloud chamber. We can't assume that it must be alpha particle or beta particle, because there are some other kinds of charged particles that can be created and projected into a cloud chamber. But anyway, this one is a good opportunity for you to have revision on this one, because this kind of question do appear in the examination. But in that case, usually they will have a little bit more information for you to fix it. From this equation, you know that if the mass and charge are fixed, for example, the question tells you that they are alpha particles. If the question told you that they are particles, then they should have the same mass and the same charge. Then the radius is solely determined by the velocity. Double the velocity, the radius will become twice. 即係如果題目講多少少嘅，話俾你聽佢係 alpha particle 嘅，咁即係個 mass 同個 charge 都已經定咗，咁你就可以話咧個 velocity 咧同埋個半徑咧係好有關聯。velocity 相配咧嗰個 radius 咧就相配。即係做呢啲題目嘅話，你一定要能夠 recall 翻呢條 formula 咁先有得做。咁啊，題目要俾多你資料。OK， 但係即係輸入咁，我哋又講一講咯。咁你遇到嘅時候，你要知道應該點樣處理。Okay, let's proceed to the next question. Number 3. Which of the following statement is true of both alpha and gamma? This one is simple. They cause ionization to the air molecule along their tracks. These are the only true one. Now B, they can be deflected by magnetic field. Correct for alpha but incorrect for gamma. C, they can be deflected by an electric field. Again, true for alpha but wrong for gamma. D, they have approximately the same penetrating power. Now, this is usually incorrect. Okay? Number 4, the rate of decay, delta N over delta T, of the number N of radioactive nuclei representing a symbol at time T is. Now, it is proportional to N. It is proportional to N. The more the molecule, the more the radioactive nuclei, the more will be the decay per unit time. So this one must be correct, proportional to n。即係你 n 咧就係成個 sample 嘅數目嚟嘅，數目越多咧，你1秒鐘入邊 decay 到嘅就會多啦，成正比嘅。咁所以呢個一定啱，其他啲都唔啱嘅。1 over t 1 over n obviously they are wrong. And why is it not proportional to t? Because it is decreasing over time. The decay will be decreasing over time. So this is definitely not proportional to time. Next one. The relationship between initial number of radioactive nuclei and the rate of decay, blah blah blah. Well, it just gives you the equation. Delta n over delta t equals to minus kn, and then n equals to n naught e to the power minus kt. So this one I already produced written on the background. Now, one of the following statements about k is correct? Now, A, k is equal to the half-life of the sample. Wrong. K is the decay constant. Half-life is half-life. They are different things. Although related, but they are different. So A is wrong. K is the number of undecayed nuclei left after a time t. So this one is also wrong. Also wrong. K is the probability of decay. Now C, K is the probability that any one nuclei will remain undecayed. So this is again wrong. K is the probability of decay, not probability of undecay. Now D. It seems that only D should be the answer, and in fact D is the answer, but it doesn't look like. Now, K delta T is the fraction of nucleus present which will decay in a small time interval delta T. It looks complicated, but if you try to rearrange the formula, then it is pretty obvious. Now, start from this one. Delta N divided by delta T is equal to minus Kn. So this is a valid formula. Now we rearrange it a little bit and move it like that. Delta n over n. So what should it equal? I move n to the denominator here. So it becomes minus k delta t. So k delta t is equal to delta n over n. But what is delta n over n? Delta n is the number of decay within that time period. So delta n over n is the fractional decay. It's the fraction that decay over the time period. So D is the correct description. It's okay? It's okay? Isn't that? Question number 6. A sample of radioactive new isotope is left to decay. After 1 minute, only 1/16 of the undecayed isotope remains in the sample. The decay constant of the isotope is now how to calculate? Now we know that after one half-life, it becomes half. Under 2 half-life, it will become a quarter. 3 half-life will become 1/8, and 4 half-life it will become 1/16. So as a result, the radioisotope has undergo 4 complete half-life in order to only 1/16 remains. And this is equal to 1 minute. 1 minute equals to 4 half-life. So therefore, half-life should be equal to 1/4 of a minute that is 15 seconds。咁1分鐘之後得翻1/10啊嘛，咁所以咧其實係經過咗4次嘅 half life 咁長嘅時間，咁所以一個 half life 咧就係15秒。Now, the question asks us to find the decay constant. How to find the decay constant? We need to use one formula on the board. I hope you still remember that we have a formula. Although I don't think you can remember, but I hope you still remember there exists a formula. And the formula is like that. K should be equal to natural log 2 divided by the half-life. In this case, it is just 15 seconds. And after you use the calculator, you end up with it is equal to 0.046 something. So the answer here is B. It is just something calculation, but you are required to remember that formula. That formula is important, so you need to memorize it. The decay constant K and the half-life is related in this way. So K equals to natural log 2 divided by half-life. 呢樣識咧係需要熟習嘅即係做親呢啲嘢都梗有機會會用㗎。因為其實咧呢一課書唔係好太多嘢可以考你嘅，咁來去都係呢啲咁嘅計算啦。Now number 7, the half-life of a radioactive element is such that 7/8 of a quantity of it decayed in 12 days. Now, 7/8 decayed, what proportion is remained undecayed? So it is 1/8. 7/8 decay 咗，有幾多被 decay 咧？就係1/8。So 12 days is account for actually 1, 2, 3 half-life。12日咧就等同於3個 half-life。Now, what fraction of it remain undecayed after 24 days? Now, once we know that the half-life is 3 days, we know that this is amount to 6 half-life. And we can continue the process. The next one is 1/32 and then 1/64. 1/64. 24日。12日係3倍 half-life， 24日咧就係6倍 half-life 啦。So the amount it remains is 1/64. The answer is C. Or to do it a little bit faster, you can just notice that 24 days is twice of 12 days. 24日係12嘅雙倍。So the amount remains is 1/8 times 1/8, which is equal to 1/64. 24日係12日嘅雙倍，咁凡係雙倍時間咧，嗰個剩低嘅份數咧就係乘大嘅。12日剩低1/8。24日咧就剩翻1/8嘅1/1，即是攞1/4。So you can think it in the other way. After 12 days, only 1/8 left behind. Leave it for another 12 days, so the remaining 1/8 will only 1/8 of the 1/8 is remaining. So it is equal to 1/8 squared, which is 1/64. Okay, so far so good. Now, question number 8. The radioactive nuclide P decays into a stable nuclide Q. The half-life of P is that symbol, T half-life. The graph below shows the decay of P and the growth curve of Q. So we see that P gradually decreasing and Q increasing over time. The curve intersects at time T. Now the time T in terms of half-life is, well, actually, the answer for this question is C. The answer is C? Because at that moment, the amount of P and the amount of Q is the same. What does that mean? That means half of the P has been converted into Q. So that time is the half-life. 呢個圖咧就比較上有啲特別嘅，就話咧去到呢一度嘅話咧，P 同 Q 嘅數目相等。咁由於 Q 係由 P 產生嘅，咁 P 同 Q 嘅數目相等咧，即是話 P 嘅半就變咗 Q。所以1/2等於1/2兩個相等。咁既然係得翻1/2啦，咁嗰個時間過咗未 ？half-life 咯。And well, we have already gone through one half-life of this double lesson. Okay. Question number 9. This one involves some calculation. A radioactive specimen decays to a stable nuclide. The rate of decay of the specimen decreases from 200 nuclei per second to 100 nuclei per second in 20 minutes. So we know that the half-life here is equal to 20 minutes. No problem. Now, what is the rate of decay in nuclei per second of this specimen after further 8 minutes? Now, this one, well, we can't do it using simple terms because 8 minutes doesn't have any specific relationship with 20 minutes. The thing we only know is that it must be smaller than 100, but should be more than 50. But which one is the likely answer? We don't know. The most unlikely answer is 59. But we still have 3 answers to guess with. So this question, you need to use mathematics to do it. No way, that is what you have to do. First thing, find out the decay constant. Now, K equals to natural log 2 divided by the half-life. In this case, we just use 20. The unit of time, as long as you are consistent, doesn't matter. 大家要留意啦，即係呢條式入邊咧 ，K 等於 natural log 2除以呢個時間咧 ，half-life 咧，用咩單位咧唔緊要㗎，呢度用分鐘照用分鐘，只要你成條題目都係用分鐘唔改嘅話咧，咁。用咩單位用咩單位 ？So calculate the decay constant first. Actually, very soon you should be able to know that natural log 2 is equal to 0.69 feet. 0.69 feet is equal to natural log 2. You no need to use a calculator. So K is 0.0347. 3 significant figures is enough because you know that the answer only have 2 significant figures. So 3 should be enough. If you wish, you can use 4, of course. Now, n equals to n naught, so this one should be like that. So you draw all the courses over the whole region. 畫滿晒成個位啦，我懶啦，唔畫咁多。Okay? So the magnetic field should be into the paper. Okay, question number 2. An alpha source is placed near a GM counter. The counter records a count rate of 50 counts per second. When a book is inserted between the counter and the radioactive source, now the source is alpha. It can be stopped by one piece of paper, so a book will certainly absorb all the alpha atom. Now the reading becomes 2 counts per second. How come there is still 2 counts? If the book can absorb all the alpha, Well, the question will reveal. Now, estimate the count rate for the background radiation. Oh, the two count rates actually come from the background radiation. Okay? So B, what is the count rate of the alpha source? So the GM counter record 50 and background is 2, so 48 is due to the alpha source. 即係嗱，you will find that once you answer, you attempt this kind of question once, you should be able to be quite sure the answer. 你會發覺咧，呢個題目你只要做過一次嘅咧，以後你見到咧，你都好肯定答案一定係咁啦。咁所以呢啲咧係值得去溫，值得去做，做完之後會食嘅一個課題嚟㗎。Okay, number 3. Hafnium-225 has a half-life of 10 days. If a sample has an initial count rate of 100 per second, how long will it be before the count is 25 count per second? Now, 100 to 25 is 1/4. 1/4. So it has to be 2 half-life, and the half-life is 10 days, 2 half-life is 20 days. Okay? So this kind of question, just write down the answer is enough. No need to solve any formula. 呢類題目咧唔需要列式嘅。Well, the formal way to do this is to first calculate K and then use the apply the formula file. But it is too time consuming. Just write down the answer is enough for this kind of question. Or maybe you want 2 times 10 equals to 20. 如果你夾硬要寫式嘅咧，2乘10等於20啦 ，OK 嘅啦，已經攞足分。Number 4, radioactivity for radon-220 decreases from 184 to 23 counts per second over a period of 156 seconds. Hey, what is the half-life of radon-220? So, well, part A, we don't have any good methods because all the numbers are not the simple one. So we need to use the full method. Oh, so we use (23) equals to 184 times e to the power minus k, and the time is 156 seconds. We use this formula to calculate the value of k. Now, although you may argue that, well, 23 is not n, well, 184 is not n naught, but this equation works. Why? Because 23 actually equals to k times n, while 184 equals to k times n naught. K is the decay constant. You multiply and you will obtain the count rate. So this formula works. 點解咧？因為嚴格上嚟講咧，呢條式咧用咧應該係 n 同埋 n naught 咁擺呢兩個位㗎嘛。咁但係 n naught 就係最初嘅數目啦。但係最初嘅數目乘咧嗰個 decay 嗰個比例嘅話 ，decay 嗰個分數嘅話咧，即係個 k 呢個數嘅話咧，咁乘出嚟咧咪就係186.4咯。一開始嘅時候 n 都咁多，但係開始嘅時候 count rate 咁多嘛。咁個 count rate 即係個 k 就係 number of decay probability 嚟㗎嘛。咁所以 k 乘 k naught 咧就會係184嘅，而 k 乘 n 咧就會等於23。So that formula is true. Now using that formula to find k, and you need to use logarithm. Natural log 23 should be equals to natural log 184 plus. This is the multiplication, so we have a plus. Or maybe, I'm sorry, maybe to save the keystroke of our calculator, we just move it into 23 divided by 184 equals to e to the power minus k times 126. So natural log 23 over 184 is equals to minus k times 156. Natural log this one, the e will disappear. Only left minus k times 156. So, do the calculation. (23 divided by 184) and then natural log it. We obtain minus 2.079 equals to minus k times 156. So I obtain k equals to 0.0133. So once we know k, what is half-life? The question asks us about half-life. T half-life equals to natural log 2 divided by k. So 0.693. This one natural log 2, no need to use calculator. 0.693, easy to remember. And then divide by 0.0133. So it is equal to 52.1. And the unit for this is second. Why is it second? Because we always use second in all our calculations. So the answer for this one should be second. The unit for this answer should be second. 嗱，點解單位 S 咧？因為一路以嚟計開咧，佢個時間單位都係用秒嘅。同你講過啦，嗰條題目，總之你統一咗用同嗰個單位咧，照用照就一定啱㗎啦。用或者你用日啦、用年啦，或者用世紀啦，咩都好啦。啊，總之嗰條題目用同嗰個單位咁就啱嘅。Now B, if the background radiation is 2 counts per second, what should be the initial count rate recorded by the GMT? So it should be 186. Okay? Now number 5. The half-life of AU198 is 2.68 days. A. Calculate the decay constant. So again, you need to use that formula. Remember? Begin to remember. K equals to natural log 2 divided by 2.68. Now, you can stack it with the decay constant using days. Or if you wish, you can change it into seconds. So I will do the calculation. Both are acceptable, but remember the units. So this one is K is equal to 0.259. Now the unit of it is day minus 1. This is an acceptable answer. Okay? Or K equals to natural log 2 divided by 2.68 times this one. So this one is equals to 2.99 times 10 to the power 1, 2, 3, 4, 5, 6. Minus 6. Now the unit of it is s to the power minus 1. 86,400 is the number of seconds in one day. I convert the time unit from days into second. Then you obtain this one. These two are both valid answers. 嗱兩個咧都係一個可以接受嘅答案嚟嘅，因為咧，但係 清楚你個單位啦。之前嗰個照用日嘅，咁咧個 time 個 decay constant 咧個單位就係 day 負一。咁如果你將個日轉咗個秒嘅話咧，咁就會計到呢個答案。咁咯，嗰個 time constant 個 decay constant 咧個單位咧就係秒負一。B. Suppose there are 7 times 10 to the power 12 nuclei of AU198 initially. Find the number of undecayed daughter nuclei after 10 days. Hello, do it. N equals to N naught e to the power minus kt. So here, N naught is 7 times 10 to the power 12. E minus now k is 0.259 and time is 10 days. So you can see that using this decay constant, it is easier. You don't need to convert the 10 days into how many seconds. That means fewer mistakes. So just do it. Minus 0.259 times 10. We will have this one times 7, 12. So the answer is 5.25 times 10 to the power 11 nuclei. Okay? So a little bit different from the answer of the book, but it should be okay. It's okay? It's okay? So after 10 days, the amount of nuclei remaining is that. Part C, found the initial activity and the activity after 10 days. Now, that will be required this number. Part C required this number. Because activity is given in backward, which means the unit is per second. If we use this number k, then we will obtain the activity per day, which is not what we need. But we can verify this by using this method. Easy. Now, activity A just equals to N naught k times N naught. It is just equal to that. So k is just 0.259 times. Now N naught is 7 times 10 to the power 12. So it is 1.813 times 10 to the power 12 per day. So this is the activity per day. In order to convert into per second, we just divide by 8,600 and 400. it is 2.10 times 10 to the power 7. So again, it is within one-off error of the calculator. Although we use this, we can still able to find out the answer. So because this is activity per day, the unit is per day, we change it back into per second, just divide the number of seconds in one day, and you will magically arrive at the same answer. So in the even in the public examination, if your answer is within calculation error, it should be acceptable. No need to worry. It amounts to the rounding off of number, so the last digit. So you better use 3 significant figure, even 4 significant figure in your calculation. This is the number of seconds in one day. Number of seconds in one day. So this is per day, so we change it to per second, so we divide the number of seconds in one day. How to calculate the number of seconds in one day? You know that 1 hour we have 3,600 seconds. We have 24 hours. 24 times 3,600 will get you 86,400. And actually, this one is easy to remember. 864 is a arithmetic sequence. 864某二幾啫。So similarly, we can calculate the activity after 10 days. 10日之後嗰個我唔計啦，因為都係咁計啫。You just replace this one with this one. Now, I want to do a little bit more. Just do a little bit more. How heavy will that sample be? How heavy will that sample be? Now, the activity is 21 millions in 1 second. 嗱，呢個樣本咧，嗰個放射性咧有幾強咧？就係1秒鐘放出2100萬個 radiation 出嚟，1秒鐘喎，2100萬個 radiation 喎。咁到底 to begin with 咧，佢有幾多嘢喺度咧 ？So we want to do an estimation. Now to do it, we have enough information to give a good estimation. Now, the nucleus is AU198. That means molar mass of it AU198 is approximately 198 gram. Not exact, but approximate. So be close enough to this number. So this is 1 mole of that. Now, there are 7 times 10 to the power 12 nuclei initially. How many moles for that number? Now, number of mole equals to 7 times 10 to the power 12 divided by number of molecules in 1 mole. That is 6.02 times 10 to the power 23. 嗱，1 mole 有幾多粒咧？就6.02乘10嘅23咁多。咁你原本有7乘10嘅12次方咁多粒啊嘛。咁你佔幾多分之1 mole 咧？就呢個同呢個咧就幾多分之1 mole。So the number, the mass of the sample should be equal to 198 times 7 times 10 to the power 12 divided by 6.02 times 10 to the power 23. This is the mass of 1 mole, and this is how the fraction, how many How many moles are there? So you multiply by the mole mass, you get the mass. Now, the answer is 2.3 times 10 to the power minus 9 gram. So, this is just only a tiny bit, very small amount of a sample can produce quite a lot of radiation. So radiation is really a kind of serious hazard because you can't see it, it is so small, so tiny, you can't feel it. Even if somebody add it into your food, you don't have noticed it. But you swallow something that gives you a lot of activity, a lot of radiation in every second. Now the half-life is 2 times. It's short. The only thing you can you will be happy about is that the half-life is very short, so it won't cause a long-term harm to your health. 計嘅目的咧，其實想你即係感覺一下，原來放射性物質咧個危險喺邊度咧？就係只要好少份量，你根本上都察覺唔到咁少份量咧，就已經咧可以放出好大量嘅輻射啦。即係如果有人要毒害你嘅話，落啲咁少嘅毒落去你嘅食物嗰度，你真係唔知咩事啦。Now, how heavy will be dust particle？ 一粒塵你估幾重咧？ A dust particle will be thousands of times heavier than that. So it is hard to imagine that radiation is okay. Now time is running out, so maybe I just stop here.